to talk about radical functions and equations. Definition. A radical function contains a radical with an independent variable usually x underneath. That's it. We've actually seen these before, back when we were talking a lot about domain, which I will get back to in just a second. Really quickly, I want us to talk about the graph of a radical function. To graph radical functions, all we need to do is use transformations. If you're feeling sort of shaky with transformations, feel free to go back and look in your notes from, I believe, that was way back in Module 1. So it's been a while. Using transformations, I believe you guys will only be asked to graph square root functions. So let's talk about what that base function would look like, right? Remember, with transformations, we always had something that we started with, whether it was given to us or something that we needed to remember, and then we would use the transformations on them. So with square root, we transform the base function f of x equals the square root of x. So what does that look like? Well, at every x value, we're taking the square root of x. So 0, what's the square root of 0? 0, right? So we have the point 0, 0. At 1, what's the square root of 1? 1, right? Square root of 1 is 1. And negative 1, but for graphing purposes, we choose that it's positive 1. 2, what's the square root of 2? Well, square root of 2 is like some decimal that's not super nice. Same with square root of 3. What's the next nice square root number? Right? What's the next number that we can take a nice square root of and get a nice answer? 4, right? And what is the square root of 4? Well, positive 2. And then the next number that we have a nice square root for is 9. Right? And it's positive 3. So hopefully this is familiar, that our graph sort of takes on this shape. Right? Square root. So I'm going to write the points on here. What is the domain of this function? Well, we scan across, starts at 0, continues onward. Cool, so that our domain goes from 0 to infinity. How did we figure this out symbolically? We talked a lot about this symbolically. Well, let's look at it. Let's refresh. to find domain of an even radical function set what's underneath greater than or equal to 0, right? We want to be either 0, equal to 0, or larger. Why does it matter that we're even? Remember that function x cubed has this sort of shape to it, right? So it doesn't stop or start anywhere. It continues from negative infinity all the way to positive infinity. So there's no domain issues with odd radical functions. But with even radical functions, we don't have negatives, right? So we have to be greater than or equal to 0. So, for example, this is just a refresher. If you feel really shaky with this, I would encourage you to go back and look at your notes for finding domain symbolically from Module 1. Domain of f of x equals, let's say, 2 times the square root of x minus 3 plus 2. Well, we take what's underneath, so x minus 3, and set it greater than or equal to 0. We bring the 3 over. We have x is greater than or equal to 3. So interval notation gives me this. Simple as that. We don't have to touch the stuff on the outside. We just have to look at what's underneath the even root. So now this brings up another question that we need to know how to answer with radical functions. How do we find the range? To find the range, we need to check for vertical shifts or flips. So this one is maybe going to take a little bit more thought. So let's look back at the same question. So range of 2 times the square root of x minus 3 plus 2. So we want to think about our transformations. So this function, we have x minus 3. What transformations have gone on here? Well, we don't really care what happens horizontally. It doesn't matter what's going on the inside. We know that what goes on the inside affects our domain, right? The horizontal stuff affects our domain, but the outside stuff affects our range, right? Remember, outside stuff is vertical. So outside affects our range. Our range of just the regular old function, remember, if we look at it, we look back at it, it goes from 0 to infinity, right? Even though it's getting large slowly, it's going to hit every number at some point. We might have to go really far, but it's going to continue to infinity. So if we're stretching, does that do anything? If I stretch something that goes to infinity, is that going to change my range? No, right? We can't stretch 0, right? 0 is going to stay put, and then everything else is going to stretch, but we don't go from 0 to more infinity, right? We're going to go from 0 to infinity still. So after we've stretched, we might want to check for a flip. If we flip, what happens? If we flip, right, our range flips from being 0 to infinity to being 0 to negative infinity, right? We've flipped under the other side, and we're going to negative infinity now. And then if we shift, of course, maybe if we were shifting up 3 or something, we would be changing from 0 to infinity to 3 to infinity. Simple as that. So if I look back at these range questions, let's look at this one. So we have 0 to infinity, we're starting with a square root function. The inside stuff we've already determined doesn't tell me anything. We have a stretch of 2. Again, that 2 is not going to affect anything. We're not changing our range from being 0 to infinity to being 0 to 2 times infinity, right? That doesn't make sense. 2 times infinity is still infinity. So the only thing here that's going to make a difference for us is this plus 2, right? We're shifting our function up 2, so our range is changing from 0 to infinity to 2 to infinity. If it's hard to think about this, then just graph it. Just graph this function and look at it. You'll find the same thing. So this plus 2 was the important part. What if we have something like f of x is negative square root of x minus 2? What do we have going on here? Well, this negative flips the function. So before, we had a range of 0 to infinity for this guy. The negative tells us we need to flip over, so we end up with everything that's less than or equal to 0. So the range is negative infinity to 0. Similarly, if we have this negative, same function, but we subtract 3, what happens here? Well, remember we want to follow along in order of operations, so PEMDAS. We flip first because we multiply first, and then we shift down. So we've flipped, so our range is negative infinity to 0, and then we shift down, we scoot all that down, so it's going to become negative infinity to negative 3. Let's try graphing something, finding the domain and range, etc. Okay, so looking at this first problem, let's find the domain and range before we graph. So my domain, we want to take from inside the function. What do we want to set this to? We want to set it greater than or equal to 0. So x is greater than or equal to negative 3. What is my range? Well, remember we only care about flips and shifts. This stretch, right, the reason we don't care about stretches is because, right, that's not going to affect our 0 to infinity. So we're starting with 0 to infinity. We don't have a flip, so it's still 0 to infinity, and then we subtract 1, so we're shifting down. So that means my range shifts down. So I start at negative 1 to infinity. Let's check and see if this is right by graphing the equation. So I want to start off with the graph, the original graph of the function. So we have that 0, 0, the 1, 1, the 4, 2, and the 9, 3. So this is my original. I'm going to do it in dotted lines. My first shift, let's start with the inside. So the inside, we have plus 3. If we have a plus on the inside, we want to do the opposite of what we think it's going to do. So we want to move to the left. So every point that I've drawn, I want to move it to the left by 3. Again, we're going by order of operations, so multiplication, y value times 2, we're doing a vertical stretch. So here y is 0, so this one doesn't move. Here y is 1, so my new y value is 2. Here y is 2, so my new y value is 4. And here y is 3, so my new y value is 6. Last but not least, we have this shift down by -1, so every point is subtracted 1. So we have 1, 2, 3, 4. So my final graph is this guy. Now let's see if this matches up with my domain and range. My domain, I scan, the first x value I have is -3, and I continue on to infinity. That's what we said it was going to be. My range, I'm scanning from bottom to top. I look across, I see that I have something at y equals -1. I continue all the way upwards, and I continue all the way to infinity. So that's what we had over here for range, so we're good there as well. So this is correct. So again, I'd like to find the domain and range. Domain of this guy, well, we want to set the stuff underneath greater than or equal to 0. That's super easy, right? X is greater than or equal to 0. We don't even have to solve, so we have 0 to infinity. Then again, we want to look at the outside for flips and shifts. We have a vertical shift of 5. That vertical shift is going to change my default range of this from 0 to infinity to what? We're shifting up 5, so what is it? Five to infinity. All right, let's graph this guy. Again, we start out with the same initial base function. Now, we want to follow PEMDAS, so we multiply first. We're multiplying by 3, so every point gets multiplied by 3. 0 stays at 0. 1 is now 3. 2 is now 6. And 3 is now 9. And what does it ask me to do next? Well, it asks us to add 5. That's really funny because we are absolutely going off the graph. We add 5 to every point, so this point is at 0. So 1, 2, 3, 4, 5. We're up here. This point, 1, 2, 3, 4, 5. This point, 1, 2, 3, 4, 5. And this point, 1, 2, 3, 4, 5. And that's my final. And again, it matches. We look at our domain, we scan across. Our first x value that we have function for is 0, and it continues to infinity. And our range, our first y value, we scan from the bottom up. We start at 5, and we continue all the way up to infinity. So this looks good. Okay, I would like to continue on to talk about radical functions and how to solve equations with them. So solving radical equations this is going to be very similar to a lot of the stuff we've done this semester. Our first step is to isolate the radical. There's a lot of stuff that we start by isolating, right? Absolute value, logarithm, exponential, a ton of stuff. then we change it in some way to get rid of it, right? If we start with a logarithm, we change it to exponential. If we start with an exponential, we change it to log. If we start with absolute value, we split it up. Here, how can we get rid of a radical? Well, you raise each side of the equation to the same power to get rid of the radical. Right? If I square a square root, we get just what was underneath, right? It cancels. Then we can solve and check. Checking is mostly important for square root stuff or even root stuff because I'm going to go ahead and stop right there because what I said next was actually incorrect. The reason we want to check with even radical functions rather than odd radical functions are because even radical functions will give us two answers, positive and negative, and sometimes only one will work. We want to pick the right one, so we need to check to see which one works. So let's try one of these. Okay, first step is to isolate. So let's get that 3 and that 2 out of there. So we bring the 3 over. And we divide by 2. Okay, we've isolated the radical. So we want to raise each side to the same power that will get rid of the radical. So if we have a square root, that's a squared. So we square both sides. If I have a square root of x plus 1 squared, that's just going to leave me with x plus 1, right? And this is going to be equal to 9, which gives me x equals 8. When we check this, we want to check and make sure this gives us the right thing. So we check 2 times the square root of 8 plus 1 plus 3. We've got 2 times the square root of 9 plus 3. What is the square root of 9? Well, plus or minus 3. We need to pick one here. For whatever reason, the answers in WebAssign assume that for square roots, the answer is positive, and it counts the negative one as incorrect. So here we actually want to assume that the square root of 9 is equal to positive 3, but we only want to do this here. Every other time we encounter a square root, we want to assume positive and negative. Again, not sure why it does that, but gotta work with what we got, right? So we get 6 plus 3, that equals 9. We're good to go. So x is 8. Let's say we're looking at something like this. Square root of 2x plus 1 plus 1 equals x. So again, we want to isolate that radical, so we bring the 1 over. We're left with square root of 2x plus 1 equals x minus 1. We want to square both sides, if you just want to write this above on the line above, that's fine, but I just want to make sure that everyone's really seeing what's going on. We square this, we're left with what's underneath. We square this right side, which involves some foiling, so we end up with x squared minus 2x plus 1. We bring over the 2x plus 1. We have 0 over here equals x squared minus 4x. The 1's end up as 0. We factor out what we can. Both of these terms have what? They have an x, right? So we have a factor of x, and we're left with x minus 4. So this means we have two answers, 0 and 4. However, we need to check, right? We need to make sure that both of these work. Let's check first 0. So I plug in, I have 2 times 0 plus 1 on the outside. 2 times 0 is just 0. 0 plus 1 is 1. I made that radical too long. So we have square root of 1 plus 1. Again, if we're assuming that we're positive, which this is the only case that we should do that in, we have 1 plus 1, which is 2. But we said that this equation should equal x, and what is x? X here is 0, so this is not correct. Let's check 4. So we plug in, we've got 2 times 4 plus 1 on the outside. We want this to be equal to 4. We have square root, 2 times 4 is 8, plus 1 is 9. Again, I made it way too big. Square root of 9 is positive 3, just in this case. So we have 3 plus 1, which is 4, which is what we wanted. So 4 works. 0 does not. Let's do one with a cube root. So I want to isolate my radical first. I bring this over. I end up with cube root of x plus 2 equals negative 4. Is this a problem? Is it a problem that I have this radical equals negative number? It's not, because what kind of radical is this? It's an odd root, right? So because this is odd, we don't have any domain restrictions. It's fine to be equal to a negative. So I cube both sides. I'm left with x plus 2 over here. Negative 4 cubed is negative 64. We subtract the negative 2 over, so x is negative 66. And I don't need to check because I don't have an even root. It's not an even root, so this is my answer. All right, that's all I have for y'all with radical functions. Thanks, y'all.